myself Manjunatha NT. Like I'll be presenting a short story assignment for this. The short story assignment is like basically we need to get a survey paper that is very recently happened, that is either 2024 or 2025, and we need to get a paper like somewhat related to deep learning or generative AI or agentic AI related to fields. So this is the like rubrics for the getting the short story and finalizing the like assignment task and other things. So this is the paper which was approved for me. So this paper contains a survey for foundational models in autonomous driving. So this was conducted by these people, and like abstract and like entire paper like available in this. So this contains a base overview of the like files that has like how many like how much time they did, and like how it's better like compared to the normal like vehicle detection, and like how large language models are like affecting the like autonomous driving, and like affected in the sense like helping is to like improve it more like easily in the manner. So I have developed the medium article also for this. So before that, like I'll present the slides for this, like explaining like what all the things like it has in a very detailed manner, like explaining the entire summary survey paper for foundational models in autonomous driving. So this foundational models transform the autonomous driving. So in this like we explore like how the foundational models are transforming like autonomous drivings, and like based upon 2020 survey by Geo et al. And these AI systems are refining like how like cars think and see and drive like in a promising safety and smarter roads. Like briefly introducing yourself to a topic and settling an aspiring tone wise. So this is like presented by me, that is Manjunatha NT. This is my GitHub repo, and like the like all the artificial and the this presentation video and the medium link, and as well as YouTube link will be present in this. So and all the artifacts of the pictures and other things like I have explained in detailed manner on this. So if you go through this repo, like you'll get a detailed idea like what happened in this, how I like added limitations and add-ons to this paper. Yeah. So let's move on to the next part. So there's a quest for autonomous driving. In this autonomous driving, it aims to match or surpass like human drivers, but traditional system face hinders. Like they build as a modular stack, separated components for uh, perceiving the environment predictions and behavior planning routes and etc for the cars. This words either struggles to scale or adapt to later scenario, like a sudden robust blocks or a complex roads or etc for this. And the foundational models like changes the game for this, like training the vast data set, billions of images, and training into the words, and like they handle multiple tasks in a one unified system, promising faster development and a better adaptability for this. And on the next we move on to the unified models. So in the unified models, like we mainly see the traditional AD systems that are puzzled with separation pieces. Like each module is separated by the like hard fit together, like updating one piece like a precision like after breaks the whole system, requiring week of tuning. Like foundational models after like unified approach, like handling the perception, prediction, and the planning into the one architecture. This leads to the coherence decisions, adaptability to the new environment, and the fast developments. The real-time example includes a Waymo's EMA, like that is Gemini based like a AI agent which predicts a trajectory's direction from the scenarios, and the Tesla transformers based full self-driving system also like comes into play for this. And the next one is the classifying of the foundational models for autonomous drivings. So to understand these foundational models, like we use the taxonomy from the survey, like splitting them into the three layers that are large language models and vision foundation models for the perceptron, and the multi-modular models for like ingestion transitions, and for ingestion tasks. So this model like aligns with four like functionalities layers, like preserve, pres- uh, preserving the environment, like predicting the behavior, like planning the routes, and like explaining the decisions. Like point to one, like in this figure, like we can see the like modularity and the functions of autonomous driving, like how the like large language models like implementing the changes, and like how the vision models like actually helping the perception and the video generation and the world modules, like how the multi-modular functions are helping into the models. So next one we move on to the large language models, that are LLMs. And so in these large language models, like a GPT-4 brings a human readable autonomous drivings. They plan routes and prediction trajectories, inject with the users, and simulate scenarios. For example, GPT drivers are fine-tuned with a LoRa, like reducing collision rate by 0.44%, like in a simulation with a BERT, like improves the like trajectories to the 7%, like on a nonsense. They also let the drivers to say like drive cautiously, tailoring the experiences, and the generate crash scenarios with adaptive with adapt generated crash scenarios. like uh, this challenges hallucinates the latency of zero point 0.2 seconds interface for this. And like after that, like we go on to the explaining of the like diagrams. So is the model prompt and the context wise, like how it's affecting the like overall score and etc. So next we move on to the VFMs. So VFMs is a vision foundational model. So in this model, like vision foundation models are highs of autonomous drivings. So excelling in a precisions in a simulation SAM A3D, like which is like object detection in a 3D, achieving 46.8 autonomous driving on a Vimeo. But the suggestions with the spares like radar data and fog. Like for simulation, like we use GAIA1. So and the driver dreams. So create the photorealistic videos and the training cars for the rare scenarios like heavy rain without real world scenarios. And the strength of the point is uh, generalizing the across the environment and the weakness of a space and etc. So this is the input methods and the world of a state auto regression predictions and the future of video frames like this, when like t1 plus 2 t1 plus 1 to 1 etc. It will go on to the, like how the real time the current image and the vehicle actions are. So and after that, like we move on to the like multi-modular functions. So in the multi-modular functions also, they combine the text images into scenarios for like holistic approach, like HIMID boost like a risk of detection by 4.8% in a value like for like spotting the hazards like a fallen tree. And also like it uses end-to-end driving like dry GPT for like hands and long tail scenarios. And expandability is to like structured action explanation, example tuning like a left due to obstacle and other scenarios. Like hundreds of like hallucination in 3D limitations are this one. And the challenges like hallucinating the false outputs, latency, and the data dependency, and sim to real gaps, simulation is real world complexes. And the responsibilities relies a risk of like adversarial spoofing is the one of the challenges they face like while developing the models of this. So and after that, like we move on to the future research directions. So in these key directions are a domain specific model training or fine tuning, like enhanced 3D scenarios for data integrations, and reducing hallucinations through the human in the loop approach of for the scenarios. Like unless until there is a driver, for example for the Tesla vehicles, until the driver puts his hands on the screen, or hands on the steering wheel, like that's one kind of detection. Or the other kind of detection can be eyes on the roads, like from the front cam of the car, like it has to detect the eyes whether the person is seeing the road or not. So it has to verify that way, and like it has to move from the next. And improving the model efficiency for comparison optimization. So large scale 2D data set training and the large scale 3D training and the planned reasoning and animation for like argument. These like combining all three can be the foundational models in autonomous vehicles. As a conclusion, we understand the foundational models significantly from like offering the adaptability, scalability, and improves the user interaction, and addressing all current limitation is crucial for safe real world development and collaboration across the disciplines of AI research and autonomous engines. And best research papers were done by the Gan Hao, and this is the research paper that was there for under their name. And here we understand the brief scenarios, like how the models are like performing in the real world scenarios, like how the LLMs are can be helping in like autonomous drivings, like how to like these LLMs can be like agentic AIs and performing their task in individually, like applying multiple like LLMs to this, like vision foundal models and multi-modals and the large language models. So all this has been written in a well documented way, like you can preview this, like understand the like each and example. Like my like the presentation is bit like messy, so you can read through this like entire document. And this video will be presented in the YouTube, and all these facts will be updated on this GitHub. uh, Thank you so much.